Hello, everyone. Thank you for joining. My name is Sonja. I come from a consultant company called Endava. And for the last 3.5, almost 4 years, I've been working on Android projects for Sony Mobile. Today, we are going to talk about Android security model and new permissions model introduced in Android Marshmallow called Runtime permissions. So let's revisit some basic concepts. Android is an operating system built on top of Linux kernel, and each application runs in its own process by a unique user, which allows it to run in an isolated environment called application sandbox, where it cannot be hindered by other applications and processes. The central design point of Android security system is that no app by default has the permission to do any action that would adversely impact the user or the system. And for any action which is not provided by the basic sandbox, application needs to explicitly request the permission. So we can say that permissions are there to protect sensitive data or critical resources. Contacts or messages on your phone are a good example of sensitive data, private data, and camera or mic can be misused, so they are an example of a critical resource. Now, let's check how permissions before Marshmallow worked. So before Marshmallow, each app needs to list all the permission it requires in Android manifest file, and in this typical scenario, when user goes to Google Play and finds the application he wants to install, the system prompts him with a dialog where he needs to accept all the permissions prior to installation. Some obvious drawbacks of this method are that user cannot opt out any permission. He needs to accept all the permissions or not to install the app at all. And as you know, in Android ecosystem, there are a lot of permissions, and this list can be quite long. The explanations are quite technical. And this dialogue is shown to the user really out of context. So user haven't yet used your app, and he needs to accept all the permissions. And last but not least, if you're developing some cool feature which requires a new permission, and after you've already published the app on Google Play, there is no way for the system to do the automatic update of your app. So once again, user has to go and explicitly approve the update. Now let's see how runtime permissions work. So the same as before Marshmallow, app still needs to list all the permission it requires in Android manifest. The difference here is that there is no dialog prior to installation, and the application is responsible to request the permission in runtime before it can use any of the protected APIs. Here, I'm showing the example of Photos app, which needs external storage permission in order to show photos and videos. So that's really a critical feature for their app. It's the main feature. So they have decided to request the permission immediately after the application starts. And this here is quite a different use case. Gmail needs contacts permission in order to show contact suggestions. So it's a nice to have feature. User can read and send emails without ever seeing contact suggestions. And that's why they decided to ask for permission only once user starts typing the recipient's email. So Google Design Pattern site has this and some other examples of designing for runtime permissions. I won't talk more about them in this presentation. One new feature in Android Marshmallow is the feature of Settings app, where user can go to settings and interact with permission of your app whenever he wants. So let's now talk about how these permissions are divided into different groups. So before Marshmallow, we had protection levels. Normal protection level should cover areas where user privacy or operation of other apps is not at risk at all, or there is small risk. Dangerous protection level, on the opposite, should cover areas where application wants to do an action which could affect user private data or the operation of other apps. And signature system are not that important for this talk, but let's just say that if app wants to get signature permission, it needs to be signed with the same certificate as the app that declared the permission. What's new in Android Marshmallow is this classification where dangerous permissions, only dangerous permissions, are divided into 9 new groups shown on the left in this table. And in the right, there are specific permissions associated with the groups. So user is now presented only with the group of permissions. It's a simplification for the user. He doesn't see specific permissions anymore. And you might already know that internet permission is not in this group of dangerous permissions. So there was quite a debate on internet when this was published, because internet permission got sort of degraded from dangerous to normal protection level in Marshmallow. An answer from Google representative was that users' private data is already protected with these dangerous permissions in this table, and there's no need to cut off data for the user. There were some other theories behind. There's some speculations about other reasons being behind this decision. And one theory is that if we would allow users to revoke internet permission for any app, anytime, we would actually allow users to use free apps without ads. And ads are still the only way of monetization for a big part of apps on Google Play Store. Now, when we talked about install time permissions and runtime permissions, let's draw some conclusions about the differences. So, in Android Marshmallow, users won't even get notified about the normal permissions that your app requires. They will be automatically granted in install time or during an update. User, as I mentioned, user now approves a group of permission, not specific permissions. And user can now go and revoke a permission and still keep the app. That was not possible before, because you had to install the app completely in order to revoke the permission. Let's now see how different API levels affect your app in terms of which model will be used. So if you go and update your target SDK version to API level 23, and your app runs on Android Marshmallow, runtime permissions model will be used. If you don't do that, or you do, but your app runs on a pre-marshmallow device, install time permissions will be used. So it looks like that if you don't update the target SDK, everything will be okay. So everything will work as before. But think about what happens if you don't update the target SDK version, and app runs on Marshmallow device, and user goes to settings and revokes the permission. So actually your app can misbehave. Because even though you're using install time permissions, and you have the permission, Google developers made sure that the API protected by the permission user revoked gets cut off for your application. They're using something called AppOps. And you will not get a security exception, but you'll get some empty data sets, error codes, and so on. Let's check some implementation details of this new model. So, first of all, this new dialog is actually a dialog style activity. And why is that important? Well, it's important to note that your activity needs to be prepared to pause and resume itself once it requests the permission. It's also important to know that your activity goes through on saving state lifecycle method when this happens. I'll talk about that a little bit later. And the third thing to note here is that you cannot put some listeners on this dialogue. The result is delivered through an existing mechanism. I will show the callback. But actually, under the hood, it uses on-activity result mechanism. Now let's see how interacting with permissions in settings affect your app lifecycle. So if user goes to settings and revokes some of your permissions, your app will be, all processes associated with your app will be killed and restarted. So that's not completely new. That can also happen if system goes low on memory. So you might be already prepared. But it's good to know that, and it's also important to keep in mind your background services, because they will get restarted as well. The opposite action, if user grants the permission from settings, will not affect your application lifecycle whatsoever. So those operations are not really symmetric, and that fact actually really pushes us to check if we have the permission each time we call the protected API. Now let me show you how to adopt this new permissions model. So there is no unique way or unique place where you can find all the protected APIs listed. So you have to locate the places where you need permissions in your code. You can use lint tool, and when you run an inspection, you will get your permission warnings under the constant and resource type mismatches. It can be useful, but it's not 100% reliable, because Google implemented an annotation called requires permission, but they still haven't put it on all protected APIs, so you might miss some places. There are some analyzer applications on the internet. I won't name them, but it's good to know that you can use them. And the third approach we used is actually testing. So based on your experience, knowledge of your code base, go to application manifest and locate all the places where these dangerous permissions are used. So before Marshmallow, we had something like this in our code, some method which reads from contact database, and that operation is protected with a dangerous permission. So in Marshmallow, now we have to check if we have the permission before we can call that method. There is a new API called check self permission, and I'm showing here methods from support library. All the new APIs are present in v4 and v13 support library. If this permission is granted, you can continue and go and read from contact database. If not, you need to request the permission. There's also a new API for that. You need to supply an array of permissions and an ID, which will be later on used in callback. So from one line of code, we went to like 7 of them. And that's not it, because there's one more API that we could use here, and it's called should show request permission rationale. So not really self-explanatory name, but it's there to help you determine if you need to educate your user more about the reasons why you need this permission. And this method will return true only if the user denied the permission once before. So let me show the example, maybe it will become more clear. So when you request the permission for the first time, the system will display this dialog. If user chooses to deny the permission, and next time when you need the permission, you decide to call should show request permission rationale, it will return true, and then you can show some details why you need this permission, and a link to settings app for the user so he can go there and grant the permission. This snack bar is one recommended way how to educate your user more. There are more ways. And if you decide to request the permission after it has been denied, the system will display the same dialog with one difference. There will be this checkbox, never ask again, and if user decides to check it and then denies the permission, the system will never prompt the user for that permission again from your app, even though you call require permission explicitly. Good information for development and testing is that if you go and clear your app data, the state of this checkbox will be cleared, and actually the entire permission state for your app will be cleared as well. So this is the callback that needs to be implemented. It quite resembles the on-activity result mechanism. There's an ID which you need to connect with the request, and then you need to verify if permissions are granted. If you look closer, you'll see that in this callback you get an array of permissions and an array of grant results. So you need somehow to map them. You can use a map or a set. It all depends on your use case, and maybe you don't even need it. And if the permission or permissions are granted, then you can go and do the action you wanted in the first place to do. Okay, so let's go a few steps back. This is the same code I showed on the first slide with code. And you might need to put something like this in on-resume. If you do, it won't work, because you might end up in infinite permission loop when user presses deny and the activity keeps resuming itself. So you need somehow to track the state. You can do that with flags to protect yourself from from requesting the permission if it's deny resume scenario. And this is actually not the only place where you need to use flags or to keep state. You need it in all lifecycle methods where you request the permission, which are called upon rotation. Because if user rotates the device while the one permission request is in progress or the dialog is displayed, he will get a duplicate dialog. There's also a problem with fragments, because if you remember, I said that your activity goes through on save instance state when permission is requested. So in some scenario, you might need to show a fragment in the callback if permissions are granted. And it's not guaranteed that the callback will be called only after on resume. It may happen before on resume. And then if you don't keep track of state, you will end up with illegal state exception. Not safe to commit the transaction. So even though this new permission model is great for the user, it's friendlier than the previous one, it can be quite painful for development. There are a lot of possible scenarios to keep in mind, especially if you're working with multiple activities and fragments and multiple permissions which overlap. The APIs are quite verbose. You have seen the callback. And the callback itself makes the code scattered. And then the code is less readable, less error prone, and we get bugs. So in my team, although my team is pretty great, which I'm not just saying because part of them are here, we had quite a few bugs with permissions. And because of that, let's talk about some do's and don'ts. So group your permission requests. If you need to request a permission in onCreate, and then you have an async task or a loader, based on which result you need a permission to request another permission, it won't work. So if you fire a permission request while one is already active, the second one will simply get disregarded. And it wasn't like that in 6.0. They've changed it in 6.01. So it's good information as well that these APIs might not be 100% forward compatible, because it's a new thing and it's changing. don't play around the groups. So don't assume that you have write context permission if you requested read context permission. Google might change these groups in the future, add a new group, move permissions between groups. And once you have updated the application to target API level 23 and published it on Google Play, you cannot downgrade it. So this happened. It was expected, of course, because our tests assumed that we have all permissions granted in install time. And the quick fix was to grant all permissions in install time. There's a quite nice ADB install-g command for that. There are other ADB commands for working with permissions, for revoking, granting, and listing them. But we wanted to do the right thing here. And the right thing is to test this new dialog and possible scenarios based on the outcome. So we then run into some more issues. We use Espresso library for functional UI testing, and Espresso is not capable of cross-app UI testing. So it cannot touch the system dialog or do any actions with it. And the second, I can say, bigger issue here is that if you revoke the permission, your application process gets restarted. So, and you might need to revoke the permission from your tests. You might want to test the approve permission scenario and then revoke that permission and test some other scenario with permission. What happens is that instrumentation runner simply fails to complete the execution when the application process gets restarted. So how did we fix this? Actually, the solution for the first issue was quite obvious. There is an UI automator framework designed for cross-app functional testing, and it works good with Espresso. So you just need to fetch UI automator objects. For this system dialog, there's a quite nice API as well, so you can fetch them by text, deny, or allow, or use some SDK tools to find specific resource IDs for this views, and you can continue to write your tests. This is not a 100% bulletproof, because in the future, package manager, that's the package that shows the dialog, can change these IDs and can change the text, so the test will break again. But that's something we will have to live with, and it's okay. The second solution is something that we are not really proud of, because now we rely on fixed order of tests. Basically, we test deny permission scenario, then show rationale permission scenario, and in the end, grant permission scenario. And we also have separate runners, one to run all our tests with permissions granted, and the second one to test permissions only. In between, we use a Gradle task to revoke the permissions. And this is something which shouldn't be done in this way. Tests shouldn't depend on each other. They should leave the clean state of your app and start from a clean state. So we don't still have a solution for this, and hopefully in the future there will be a better way to do this. So this is the end of our journey. We talked about install time permissions, runtime permissions. I've showed some code, not so nice code, and we talked about permissions. So thank you, that's it.
Any questions maybe for Sonja? Oh, sorry.
Hi.
Hello.
So in one of the examples you showed that in the case where you should show a request rationale, then you're showing a snack bar with a link to settings. But in this case, wouldn't it better to allow the user to retry the dialog? Because it's possible that he didn't select never ask again.
Well, Thank you for the question. This is basically a demo app. I wanted to show what you have, what APIs are available. But basically, it's up to you to decide what do you want to do in your app. And there are some guidelines to follow. This should show request permission rationale. It's not mandatory, so you don't have to use it at all. And yeah, you're right. You could show the dialog once again to the user.
Okay, and another question, is there a method to check if the user selected never ask again? Because I think I didn't find one.
No.
No?
Unfortunately not. So basically what you can do, I don't recommend it, we did it. So you keep some states in your shared preferences or everything, because the first time you call should show request permission rationale, it returns false. Once the user denies it, it returns true. If you check these states, you can keep your own state, oh, user pressed, never check again.
That's what we did as well. I was wondering if there is a better solution. Okay,
no, that I know of.
Okay, thank you.
Thank you for your question. Anybody else? Was that hand in the air or just no? Scratching your head. That's also okay. Anybody else? Not scratching, but trying to ask a question. No, thank you very much. Thank you very much. Sonja, please, a big applause for our last speaker today. Thank you so much.